Hello, Etans. I hope you are well. Our today's lesson is going to be on C4 topic, and we're going to look specifically on electrolysis. So we're going to start with key points. I'm going to discuss with you how actual electrolysis takes place, and we're going to look at two examples of electrolysis. There is more to that topic than the bits that we're going to discuss today. But we will do that in the next lesson. So today is mainly about the basics of electrolysis. We're going to look at how does it work. So the key points are, so what is electrolysis? Well, electrolysis is splitting up compounds using electricity. Now think about what electrolysis. It comes to mind first thing, it's electricity. So electrolysis is splitting up compounds using electricity. Now, electrolysis takes place in ionic compounds. Now, what does it mean, ionic? Ionic compounds, okay, it means, what are ions? Well, ions are atoms with charge, so it means ionic compounds. So they are compounds which got positive charges and negative charges, and that is a very important point of electrolysis. And also, electrolysis only takes place in substances that are molten or substances that are liquid or they are dissolved. Molten means we just heated up the substance which melted, and liquids usually we dissolve using water. Now, why we can do for electrolysis only in molten and liquids? Now think about arrangement of particles in solids, liquids and gases. Now in solids, really, particles are arranged something like this. Think about this. What are those particles like? What is the attraction between them? Well, the attraction is very strong, so they cannot move around. Where in substances that are molten liquids, particles are free to move. Okay, and we're going to discuss this bit later on why this is important. Now, let's look at the basics. So how does it work? Let's have a look. How would we set up electrolysis experiment? So I've got a container. In the container, I will submerge two electrodes. That's what we call them. So they're called electrodes. Okay, those electrodes are going to be connected to the source of electricity. So at school we use a power pack. Okay, so this is source of electricity. Okay, now one of them is positive, so the dot to which we connect the electrodes, one of them will be positive, one will be negative. So the electrode that is connected to the negative dot is negative, the one that is connected to the positive dot, it will be of course positive. Now those electrodes have also got names, and those names are panic. Easiest way to remember. Positive is anode, negative is cathode. Okay, so positive is anode, negative is cathode. Panic, the easiest way to remember. Now, and also in the container I will have a substance that is either molten or is a liquid. Okay, and that we call electrolyte. So it's the substance that is liquid or liquid. I need to start writing faster. Liquid or it's a molten substance. Okay, now this is the basic. Okay, please remember how we set up the experiment. Electrodes are mainly made of graphite. Forgot to add that. Graphite. Now, why graphite? Well, graphite is the only non-metal that conducts electricity, and in electrolysis it's very important that we're using non-metal. Okay, and it's only made of carbon, so have got no ions really. Okay, so this is my basic diagram. Now let's have a look how electrolysis will take place in the molten and liquid. So electrolysis takes place in two types of substances. So they are molten and solutions. Okay. Now we're going to start with molten because they're much easier. So molten means that we literally heat up the substance, still will melt, and that's all what it is. Example. So we're going to start with the most common example, and that will be sodium chloride. Now sodium is a metal, okay, so sodium will be a positive ion. Now why sodium is a positive ion? Well, because sodium is in group 1, so it means I've got 1 electron on outer shell, and when sodium reacts, it will lose that electron and becomes positive. That's why we say sodium is a positive ion. So in general, all the metals are positive ions. Chlorine will be negative ion, and because chlorine is in group 7, okay, so it means I've got 7 electrons on outer shell, so chlorine will gain electrons. So when you gain electrons, you become negative. Okay, so that's why chlorine is going to be negative ion. Now, so this is ionic compound, sodium chloride. So again, let's draw it out. So there you go, my container with 2 electrodes in it. Okay, now one of them is a positive electrode, the other one is negative. Okay, and inside we've got sodium and chloride ions. So sodium positive, chloride negative. So I hope you do remember this from lesson. So sodium ions are positive, so they will be attracted to a negative electrode. Okay, so sodium ions will be attracted to a negative electrode because opposite charges attract. And literally, that's the question you can get on your GCSE exam. So they will say to you, why sodium will deposit on negative electrode? And then you say, oh, because sodium is a positive ion and opposite charges attract. On the negative on the positive electrode, we're going to have ions of chlorine and chloride, because it's an ion, so chloride. Chlorine is an atom. So ions of chloride are attracted to the positive electrode because because chloride is negative, so have got negative ions, so opposite charges attract. Now key points in it, that's it. Okay, so positive ions of sodium are attracted to negative electrode because opposite charges attract. Chloride ions are attracted to the positive electrode because opposite charges attract. So let's write this up. So Na plus is attracted to negative electrode. I'm not writing negative, but you probably in your notes you will have to write negative electrode because opposite charges attract. Okay, charges attract. Very important thing in here, sodium ions gain electrons. See, gain electrons and become neutral. Now neutral, and sodium deposits on electrode. So that's the key point. Now why sodium gains electron to become neutral? Think about this. In the first place, sodium was a neutral because it was an atom, so it had no charge. So how sodium became positive in the first place? Well, because it lost electrons. So now sodium wants to go back to being neutral, so it needs to gain electrons. So when we say it will gain electrons, so all the metals, okay, when they get to a negative electrode, they will gain electrons. Okay, in this case, sodium will gain only 1 electron to become neutral. Key points from here: So sodium is attracted, that's a keyword, to the negative electrode because opposite charges attract. Very important. You get marks for it. And then sodium deposits on electrode. Okay, don't forget always to say that sodium is a positive ion or negative ion. So how will that work for chlorine? I'm not going to for chloride ions, I'm not going to write this down. You can if you wanted to. So chloride ions are attracted to the positive electrode because opposite charges attract. Chloride ions will lose electron to become neutral. Okay, why lose? Well, think about this. Chlorine atom is neutral and it gains electron to become negative. So he wants to go back to being neutral. So what does he have to do? Well, he has to lose that electron to go back to neutral. Okay, and then chlorine atoms deposit on electrode. Now, chlorine deposits as gas. Okay, so if you do experiment, you will be seeing bubbles in here. That's it. Okay, so this is electrolysis of molten substances. Okay, so we look at electrolysis of molten solutions, of molten substances. Now we're moving on to solutions. Now, if we talk about solutions, it means that we add water to make a solution. So if we talk about water, we need to know about ionic representation of water, which is H plus ions plus OH minus. And I'm sure you remember this from our previous lessons on neutralization. So let's have a look at exactly the same example. So we've got sodium chloride solution and we're doing electrolysis of that. So let's have a look. So we again draw out our container. This one is a bit wonky and electrode became a bit smaller. There we go, much better. Okay, so again, I've got a positive electrode, negative electrode. It doesn't matter which one's positive and negative. It's just the way I got used to it. I just say the first one's positive, the second's negative, but it's irrelevant. Okay, and so I know I've got sodium ions and chloride ions. So one of them are negative, the other one is positive. Okay, so sodium chloride. So I've got those ions, but I've also got the ions which comes from water, which will be H plus ions and OH minus ions. Now in electrolysis, only one type of ions can deposit on one electrode. Okay, one element can deposit on electrode. So I know I've got sodium chloride, so sodium chloride, and I also got hydrogen and hydroxide ions. Okay, now only one positive ion can deposit on negative electrode, and only one negative ion can deposit on positive electrode. How do we solve this? Well, let's have a look at the first part. So I've got sodium ions and hydrogen ions. In here, you have to remember the rule, and there's quite a few rules in when we talk about electrolysis. We're just going to do one example today, and then next time we're going to go into a bit more details. Less reactive element will deposit on the electrode. So we'll deposit on electrode. Okay. Now, how do I know which one is less reactive? Well, you need to know your reactivity series. And when you look at the reactivity series, sodium is higher in reactivity series than hydrogen. So it means hydrogen, because it's less reactive, will deposit on negative electrode. There we go. So hydrogen will deposit on negative electrode. Okay. And hydrogen will gain one electron, become neutral, deposit on the electrode, and also is produced as a gas. There we go, it's a gas. All right, now negative electrode, positive electrode. Well, we've got in here two elements. We have chloride ion, and we've got hydroxide. Now, there's another rule. If one of the elements is a halogen, that's the element that will deposit on the electrode. Okay, so if you see that this is chloride, chlorine, fluorine, bromine, all those elements will deposit on the electrode because they are halogens. Okay, so they are in group 7. There you go. So group 7, so if they are halogens, group 7, they will deposit on the positive electrode. So in here, we're going to get chloride ions. There we go. They will be attracted to the positive electrode because chlorine is negative, so opposites attract. Chloride ions will lose electron, become neutral, and they will deposit on the electrode. There we go. And they will deposit as gas as well, so we will see bubbles, lots of bubbles. Okay. Now, what happens during in solution is a bit more complicated, but there are simple rules that you do have to remember. Okay, so just make sure that you learn them. Okay, but actually electrolysis is fairly simple because it's all the same thing. The positive ions are attracted to negative electrode because opposite charges attract. Positive ions will gain electron to become neutral and deposit on the electrode. Negative ions will lose electrons to become neutral and they deposit on the electrode. Simple as that. That's all what it is. Okay, so let's have a look. How would that look in the questions? Now, foundation and higher students, you've got different types of questions, but one of the questions is exactly the same. Is the question about magnesium chloride, and there is a question. There are 2 questions. Okay, explain. So let's go from beginning. This question is about magnesium and magnesium chloride. Magnesium chloride can be electrolyzed. The diagram below shows 2 experiments for electrolyzing magnesium chloride. So you've got the first one. Have a look at the labels. The first one says, right, so power supply, positive electrode, negative electrode, molten, and this is really important, molten magnesium chloride. Magnesium chloride. Okay, which one is positive, which one is negative? Do I have water ions in here? Well, no, because it says molten, so just magnesium chloride. Okay, in here, experiment 2, I've got positive electrode, negative electrode, magnesium chloride dissolved in water. Dissolved in water means that I've got addition of water, of H2O, means I've got H plus OH minus ions. Okay, and the question is, explain why magnesium chloride must be molten or dissolved in water to be electrolyzed. Have a think about the diagram in here, okay, and have a think about what we discussed in regards to substances as more. Sorry, I'm just looking for a. There we go. I think we talked about this slightly at the beginning. So we said that electrolysis only takes place in molten substances or substances that are liquid. Why not in solids? What do you think are particles like in solids? Well, they're very attracted to each other, so they can't move. Okay, so imagine if I put ionic substance in here, do you think that would work? Yes or no? Why? Okay, so the question is explain. So tell me why magnesium chloride must be molten or dissolved in water to be electrolyzed. Okay. Second question is explain how magnesium is produced at the negative electrode in experiment 1. That's your experiment 1 in here. Oops, that's your experiment 1 in here. So why magnesium is produced at negative electrode? So if it's produced, something is produced at negative electrode, what ions that will be? Okay, so you have to think about this. A little hint: magnesium is in group 2. Okay, so we'll have 2 electrons on that shell. So magnesium will lose or gain those electrons. Well, it will lose electrons, so it will be positive ion. So a bit of a hint: it's a positive ion, so it's +2. Okay, chlorine is in group 7, so chlorine will have negative ions. Okay, so it'll be minus. There you go. Good luck. Once you finish, there is a mark scheme at the back. Okay, can you make sure that you finish all the questions which are set for this session, and can you please take a picture of your work and send it to me through Satchel 1. Thank you very much, Year 10. I hope to see you soon at school. Take care. Bye.